Take a deep breath for a moment. Before we even begin, try to picture the biggest thing you can imagine. Maybe it's the Earth, or the Sun, or our entire solar system with its planets stretching billions of kilometers across space. Now here's the uncomfortable truth. Whatever you're imagining right now is laughably small compared to the actual size of the universe. And by the end of this video, that idea of big you started with is going to feel completely broken. We live on Earth, a planet about 12,000 kilometers wide. From our perspective, that already feels enormous. You can spend your entire life traveling across it and still never see everything. But Earth is just one planet orbiting one average-sized star we call the Sun. The Sun itself feels massive to us. It holds more than 99% of all the mass in our solar system. If you lined up over 1 million Earths, you could fit them inside the Sun. Yet in the cosmic hierarchy, the Sun is nothing special. It's a fairly ordinary star, one of hundreds of billions inside a single galaxy. Our home galaxy, the Milky Way, is so large that light itself takes about 100,000 years to cross it from one side to the other. Let that sink in. Light, the fastest thing in the universe, traveling at nearly 300,000 kilometers per second, still needs 100,000 years just to go across our galaxy. Inside this vast disk are hundreds of billions of stars, many of them with planets of their own. Some of those planets may have oceans, some may have atmospheres, some might even have life. And all of this exists within just one galaxy. Now imagine zooming out. The Milky Way isn't floating alone in space. It's part of a small collection of galaxies called the Local Group. This group includes the Andromeda Galaxy, which is actually on a slow-motion collision course with us, along with dozens of smaller galaxies. The distances here are already so absurd that numbers start to lose meaning. Andromeda is over 2 million light-years away. The light reaching us from it tonight left before humans even existed. But the Local Group is just a tiny neighborhood in something far bigger. Zoom out again, and you'll find galaxy clusters, massive structures containing hundreds or even thousands of galaxies bound together by gravity. These clusters then form superclusters, vast cosmic webs stretching across unimaginable distances. Our galaxy cluster is part of the Laniakea supercluster, which spans over 500 million light-years. At this scale, galaxies look like tiny specks connected by filaments of dark matter, with enormous voids of nearly empty space between them. Here's where things start to get truly mind-bending. When astronomers observe the universe on the largest scales, they see a structure that resembles a three-dimensional cosmic web. Galaxies and clusters sit along long filaments, while gigantic voids, some hundreds of millions of light-years wide, contain almost nothing at all. These empty regions are so vast that entire galaxy clusters could fit inside them and still leave plenty of room to spare. Now let's talk about the observable universe. This is the part of the universe we can, in principle, see. Not because it's all that exists, but because light from beyond a certain distance simply hasn't had enough time to reach us since the universe began. The observable universe has a radius of about 46 billion light-years. That means the full diameter is roughly 93 billion light-years across. And remember, the universe is only about 13.8 billion years old. The reason the observable universe is so much larger than 13.8 billion light-years is because space itself has been expanding the entire time. And that brings us to one of the strangest facts of all. When we look at distant galaxies, we're not seeing them as they are now. We're seeing them as they were billions of years ago. Some of the galaxies we observe today no longer exist in that form. Some may have collided, merged, or changed completely. The universe is like a time machine where looking farther away means looking deeper into the past. But even the observable universe is not the whole universe. It's just the part we can see. Beyond that cosmic horizon, space continues. How far? No one knows. It could be finite, wrapping around in some higher dimensional geometry. Or it could be infinite, stretching on forever with no edge at all. If the universe is infinite, then everything we see is just an infinitesimally small patch of a much larger reality. And here's a thought that truly stretches the mind. If the universe is infinite and the laws of physics are the same everywhere, then somewhere out there, unimaginably far away, there could be regions almost identical to ours. Galaxies arranged the same way, stars similar to our sun, planets like Earth. There could even be versions of you, living slightly different lives, making slightly different choices. Not because of science fiction, but because of pure mathematics and probability. Now let's talk about scale in another way. Distance alone doesn't fully capture how big the universe is. Time matters too. The universe has been expanding since the Big Bang, and that expansion is accelerating. Galaxies aren't just moving through space. Space itself is stretching. carrying galaxies along with it. This means that distant galaxies are receding from us faster and faster. Some are moving away so quickly that their light will never reach us, no matter how long we wait. They are already beyond our cosmic reach. This leads to a sobering realization. Over time, the observable universe will actually shrink, not in size, but in content. As space expands, more and more galaxies will cross the cosmic horizon and disappear from view forever. In the far future, distant galaxies will fade away, leaving only our local group visible in the night sky. Future civilizations may look up and see a much emptier universe than we do today, unaware of the vast cosmic structures that once filled the sky. And yet, despite all this vastness, the universe is also incredibly precise. The same physical laws that govern an apple falling from a tree also govern the motion of galaxies across billions of light years. The same equations describe the behavior of atoms and the evolution of stars. This consistency allows us to understand a universe that is far larger than anything our minds evolved to comprehend. Our brains are simply not built to intuitively grasp these scales. Evolution prepared us to survive on the savannah, not to imagine distances measured in billions of light years. That's why the universe feels abstract and unreal when we talk about it this way. Numbers lose their emotional impact. Words like billion and trillion blur together. But the reality is that each of these numbers represents real space, real time, and real physical processes happening right now. One way to make this more tangible is to compress the universe into a scale model. If the sun were the size of a grain of sand, Earth would be a microscopic speck orbiting it. The nearest star would be several kilometers away. The Milky Way would be so vast that it would stretch far beyond any city, and the nearest galaxy would be thousands of kilometers away. Even in this drastically scaled-down model, the universe would still be too large to meaningfully visualize. And here's another humbling perspective. All of human history, every war, every civilization, every idea, every moment of joy and suffering has occurred on a tiny speck of dust suspended in this incomprehensibly vast cosmos. From the universe's point of view, humanity occupies no special location. We are not at the center. We are not privileged observers. We exist in an ordinary galaxy, around an ordinary star, on an ordinary planet. Yet somehow, this ordinary planet produced minds capable of asking extraordinary questions. The universe is vast beyond comprehension, but it is also knowable. Through science, mathematics, and observation, we've managed to reconstruct a picture of a reality far larger than anything we directly experience. We've measured the age of the universe, mapped its structure, and traced its evolution from a hot, dense beginning to the immense cosmic web we see today. And we're still just getting started. New telescopes are pushing our vision deeper into space and further back in time. We're discovering galaxies formed just a few 100 million years after the Big Bang. We're learning how dark matter shapes the universe and how dark energy drives its expansion. Each discovery makes the universe feel both more understandable and more mysterious at the same time. So the next time you feel overwhelmed by the size of your problems, remember this. You live in a universe so vast that your mind can barely contain the idea of it. And yet, here you are, a small collection of atoms that somehow became conscious enough to look out into the darkness and understand it. The universe is far bigger than you think, but the fact that we can even begin to grasp it might be the most astonishing thing of all.